Good morning
Good morning.
or good afternoon. Actually.
Afternoon indeed.
What?
I have developed I need people to tell me what I have developed.
What? Say again?
I think I've developed something a bit unexpected.
Developed something it's unexpected. What was that?
I'll show you. I'll show you.
Oh,
But if it's only us, we don't need to record today, I guess.
I have Chris. I have Chris here. Let me admit
Ah,
him.
good. Why don't I see? Oh, wait. Do I see them? Yes. Excellent. Oh, good. We have lambda calculus to talk about. Hello, Chris. Hey.
Hello.
Chris, would you happen to be interested in talking about those lambda calculus PRs today?
Yes, at least some of them that I depend on, probably.
Yeah. Okay. Very good. So before I do that, let me show you something very weird. Something very weird. So Alexander, you know modal logic, right?
Uh-huh.
Yeah. So I've been playing with modal logic, and I've done this. I've so modal logic in here we have it's parameterized over the type of atoms.
Mm-hmm.
And so on Monday or slightly before, I don't recall, I thought, what happens if I instantiate atom with prop?
Mm.
Do I obtain a modal logic on lean propositions? That was the thinking. And what does it mean? Can I use modal logic to reason about lean statements? And the answer, which will hopefully be clear in 5 minutes, is yes. And it turned out to be quite interesting. So there's now a wonderful lean file inside of modal logic. There are at least two very interesting ways to reason about lean using modal logic. One is you give me a relation, any binary relation, right? And then I give you a model. In the model, the relation is the relation you gave me. And the valuation, every atom is a lean predicate, right? That just tells me whether the predicate holds at the current world. So basically, the model I get is a model where the worlds are just elements of this type alpha, and the atomic propositions of the logic are lean predicates of type alpha to prop. And I can do lots of stuff with that. Another very similar thing is something, once you discover how to do that, then it becomes very easy to do a model of sets. So you give me a relation, and let's say that atomic propositions are containers of these elements of alpha. Like, for example, a beta could be a set of alpha. But it could also be anything else. Could be a list, whatever it is. So now I give you a model where the relation is the relation. The elements are the elements of type alpha. And the atomic propositions are collections of these elements. And then the valuation is just, well, the current world is in the container that you have put in the atomic proposition. Okay? Now, out of that, I get some theorems. For example, under the predicate model, the atomic proposition is valid if and only if it holds at that world, and so on and so forth. But what's interesting is what you get out of it, because now you can define, axioms in logical equivalence and logical equivalences on these things. So then I started playing. I started playing with what is one interesting lean model. And I defined this.
Mm.
And now it gets weird. So, given any type with a scalar multiplication,
Mhm.
okay, in Linus mu, then I can define an accessibility relation whereby x is related to y, or from x you can go to y, if there exists some factor that you can use to multiply x and get y. Okay, so x goes to y if y is basically the result of multiplying x with something.
Uh-huh.
Now, if this, this is a monoid action, so you started from a monoid, I can prove that this relation is always reflexive.
Mhm.
If you started from a semigroup, I can prove that this relation is always transitive. And if you started from a commutative semigroup, I can prove that this relation always has the diamond property, as we have defined in CSLib. Okay, now this is a very interesting relation, and I get it for every freaking monoid or commutative semigroup, right? You don't need to tell me what it is. I just get a relation with this stuff. And the model logic is very powerful when you have these properties. When you have transitivity and diamond property, then you get a truckload of axioms, right?
Uh-huh.
So then the question is, what can I use it for? Okay, here's an interesting one. This is just what I've shown you, but where I define the relation on a specific scalar multiplication operation, which is exponentiation.
Uh-huh.
So x reaches y in the relation if you can do x to the power of something, whatever it is, and then the result is y.
Uh-huh.
Okay. All right. Now, I define as my atomic propositions in the model logic ideals, straight from MATLAB. Okay. So it's a submodule, if I remember correctly, how they define it. And now we don't need to get into theory of ideals, but ideals they define a concept of radical. You can take the square root or the root of an ideal. You get the set of all the radicals in the ideal, basically.
Uh-huh.
Now this means that my relation you can go since it's the relation that connects all elements that can be obtained by doing the first element up to the power of something. You can go back and forth, and you can reason about exponentiation of ideals, or if you go in the opposite direction, radicals of ideals. And now something surprising is that if you take the radical of an ideal under this relation, the set is equal to the denotational semantics of diamond of the ideal.
Mm.
And the proof is trivial because it's basically by construction of the relation. So I've hammered the definition until I could get something interesting is equal to the denotation of a formula, right?
Okay.
Now this means I can forget about radical. So any property you want to prove about radical, if you can prove it about this, then you're good. So we can forget about radicals, we can forget about algebra, and now we play with model logic.
Mm-hmm.
So play. I have reproven in a different way that this is called radical inf in MATLAB, which is that if you take the radical of the intersection of two ideals, that's equal to the intersection of the two radicals. The proof doesn't expand anything. It just says, well, let's switch to model logic because this is equal to the denotations, right? So basically, this makes this go from this to diamond of that, right? That's what it does.
Uh-huh.
And then these I just translate by the same rewriting into diamond I
Diamond.
and diamond
J.
J. So now I just need to prove. I just need to prove this. This is a pure modal logic thingy. I have an axiom that I have proven that, you know, if you have an operator like this that becomes AND, which it does for all sets. It's not even ideas. It holds for all sets. So I do this with, and now I just need to prove this this formula, and I use logical equivalence. It's just a rewriting. I go here. Sorry. So there you go. Here I prove the equivalence. The equivalence has a diamond, so then I use congruence and logical equivalence. But I forget about the algebraic properties of ideals. And I don't know. That's it. So that's the weird. So so we already have something that you can use to prove mathematical theorems using our formalization of modal logic. And this is general. Whatever monoid action you have, you can apply this thing. And you know, now here I wanted to do the proof manually to show that well, the argument, right, the structured argument. But you can also just, you know, invoke a grind, and grind will translate it to a denotation, then from a denotation to our satisfaction relation for modal logic, and then it will use all the theorems it has there and try to call it a day. I think the proof in grind is a tiny bit different because of how grind works, because well, actually, it has multiple ways of doing it. Interesting. So in one, it uses intersection and so it's more direct, I would say. It's more direct because it goes directly and sees that it's a set, and then you get that this is the same as this, as I and J. But this is something that I think we should ask ourselves in the background. Now I've already spent a lot of time on this, but I'm going to put this up as an example in a PR. Like, this is possible. You can take any, I think, interesting kind of action, and you can get a relational view, and then you can reason about the relation. So it's all about, does reasoning about the relation correspond to what you were interested in thinking about? So, for example, I could do it for radicals. Probably you can do for many other things. I think the same reasoning would work for divisibility, for example. So same thing, right? You can define the relations as that it uses multiplication instead of power. Done. And I do wonder if, well, how we could use this. Because it's surely full of other things. I was thinking another cool example could be lambda calculus. Can we prove because you know you take the multi-step relation that is transitive, and in the semantics we have, it also has the diamond property, so you actually get a lot. And I have proven. Let me see. Loeb's theorem. Here we require well-foundedness, of course. But if you have a well-founded relation, then I can basically give you a principle of induction. I think from this I can derive the strong induction principle in Lib, right? I can prove it correct. I think we can reprove Gödel's theorems with some of this stuff, with a pure modal logical argument, maybe. And usually that's a pain to do. So there's also something I would think of trying. And I wonder if we can use, you know, the diamond. I think I have it in lean. Anyway, can we use this stuff to prove a type preservation or type safety? Maybe we can. With type preservation, I have defined a thing in relation. Let me see if I can get it. I have defined preserves. So a relation preserves a property if you go along the relation and the property still holds for all elements that you can reach. That's probably type preservation, right? You were well typed before, you're still well typed. Preservation gives the fact that you can do one step.
Mm-hmm.
So progress is also something we can express like this. And I wonder if we can express this in modal logic, or is there even can modal logic help improving typing preservation? Now, the details are always, on the concrete types that you're looking at, like the ideals have a closure property that I'm using. In lambda calculus, you actually will have to prove that for every term, you will still need to prove that it's well typed. But what I wonder is, instead of asking people to imagine the strategy manually, can we hope to use modal logic to just guide, well, your formula looks like this, so you're going to use this axiom. Done, right?
Mm.
In the end, this is equivalent to invoking the right lean tactics, because in the end, we produce a lean proposition with a satisfaction relation. But I do wonder if it gives some structure. Maybe we can even make a tactic, an interactive tactic, I don't know. Because it's easy to, I mean, in a lot of cases, it's very easy to guide the proof search in modal logic, right? So it depends on how the formula looks like. Anyway, this is just one episode of maybe trying to do a logic very, very carefully and generally pays off. I think now I'm also getting very near. I'm going to have a chat with Thomas about that. I think I'm getting near to making a type class for all modal logics that captures at least both the modal logic we have and the similar logic, because now the definitions are really the same.
Uh-huh.
And you instantiate that class, I think what I can give if you instantiate the class is automatically the right definition of logical equivalence. Hopefully, because that now the theorems really almost all look the same. So we'll see. Anyway, the same can be done for LTS. I have checked. And so, yeah, it's interesting. At least I'm having fun. We'll see. I'll ask you and Thomas to review so that you can get a big headache out of my code. But it looks, I mean, it's complex only superficially. It's really just give me a scalar multiplication operator, I give you the relation. There you go.
Mm-hmm.
All right. So,
Amazing.
shall we talk?
Yep.
Again, sorry?
No, just said that it's amazing, interesting.
Well, it's nice. There are a lot. I didn't find this particular way of doing things in the literature. I've talked to a few colleagues, but I have to look into it a bit more. A lot of people know that given a generator, you can interpret it as a relation, and then you can get a modal logic out of that. But they've used it for different things. I haven't seen it used exactly like this. But the really nice part is that it actually works in Lean. Like I could write these ideas in Lean, and it works. So that at least gives me some hope that we are doing the formalization correctly. All righty, shall we look at some PRs that are stuck in...
I mean, we could perhaps look at the named representation PR. That's, wait, I had it open because I depend on it. 458.
458.
458. Because I think Chris Hansen just said that, well, he's fine with it as long as, I think there are just merge conflicts or something.
Okay, how complicated? I mean, it's only in the CSLib file, so probably.
I mean, I'm not sure who's supposed to close those, because I think the PR opener didn't do anything since then.
Let me try.
Maybe we don't have to do it now, but just thinking because I'm doing the alpha equivalence PR in parallel, and this one depends on it. So yeah.
But that's actually I think it's okay. Also, as Chris Henson says, to merge this also because we have active work waiting on this, and your PR actually fixes my last qualm about this. We should prove that the pen and paper alpha equivalence is the same as this alpha equivalence, right? Such that at least we know it's adequate. Well, assuming the old alpha equivalence is adequate, but that's another story. Then we have tests. So I think here, as soon as CI goes through, we are good. And then what do you have that depends on that?
I have to look up the number. I think it's somewhere in the 700s. Wait a second. It's 741, but I still have to adjust it to the last state of this PR because it's some time ago. But actually, I'm mostly done with this alpha equivalence paper. So I, at least not in this PR, but in the follow-up PRs, I can show that all the alpha equivalents are equivalent. So this is something that will come up the following PRs. I hope so.
Yes, I'm looking at it in another window. Yeah. Did anybody review this already? Christian needs to have a look at it. Okay, cool.
Oh, I think I had network issues, right? Was I cut off for some time?
No, I mean 741.
741, exactly. Yeah, but nobody looked at it at this time.
Okay.
But
I've asked
as soon as the this PR is done.
Yeah. 741 maybe. Let's see if how long does our CI take now? But is it linting? It's linting. Okay. So at least it the CSLib file should be okay now to compile at least. Linting passed. Checking the CSLib file. Done. What suspense? There's been a discussion about, all this notions of alpha equivalence, like the named representation is a pain, but I actually think in lean is a bit less of a pain, especially with this new definition. But let's see how much we can automate things.
I mean, my long-term goal is actually to prove it equivalent to the. There's another PR for De Bruijn, and I found a paper which shows that the quotient form of alpha equivalence is equivalent to De Bruijn, which could
because that's
help to some
it's
degree.
Not exactly, it's not exactly like De Bruijn, but if you take the quotient, it should.
Yeah. I mean, I think that's the long-term goal to show that the binding representations are somewhat equivalent to some degree.
Look, this is basically the reason for which I put that. Well, one of the reasons, but one of the major reasons for which I put the definition of pen and paper like alpha equivalence.
Yeah. Exactly.
So that we can finally prove De Bruijn correct.
Yeah.
Because otherwise, I think it's correct, but better to know.
I mean, it's very hard if you work for a long time with all these alpha equivalences. Like, you are so focused into some minor problems, and you really lose the big overview in the long term.
Yeah. Let me see. Somebody's asking for the link, but the link should be at the top, right? Maybe we should put this link on our website, Alexander. There you go. We are almost there. Et voila. Excellent. Let's get it in. It will get in 10 minutes after rerunning the CI, I guess. So that's very good. And then next we're going to look at 741. And now maybe since we can hope that, for example, now that this is merged.
I mean,
This
like I
was,
said, I
for-
will probably adjust the properties that were proven because some of them are more easily proven after I show some equivalences. So I will
Yeah.
refactor some of it. But yeah, the main idea is to show like 5 different alpha equivalents are equivalent.
Very good. 741 alpha equivalency. Do we already have a thread for 741?
In CSLib,
Yes, we do.
yeah, some time ago, I think. Yeah.
Okay, so I'm going to inform who, what was his name? Hao Xuan Yin. That we have merged the CSLib 458. Somebody is waiting to get in, or no? I have somebody messaging me that they can't get in. Okay, but just a second first. So Chris will let you know. So you need to do some work on this one first, right?
Yes, some minor work. It's probably going to happen this week.
Okay, then can you ping us in the PR review topic
I will
for
ping
your
you.
PR, and then people can have a look.
I will ping you.
Voila. So do we actually have a broken link? I'm here in the meeting. The meeting link looks correct. All righty. So this is still for the untyped lambda calculus, right? Oh, hi.
Yes, it's really untyped. I'm currently mostly focusing only on untyped lambda calculus for all the things I do because perhaps for some context, I'm doing this for my graduate studies and some research in computer science. And well, we are just going, okay, I've no real background in lambda calculus, so I'm learning iteratively till I hit type theory to some degree. And well, yeah, next semester we'll go into type theory, and I hope to formalize a lot of stuff there as well. Then.
Very nice. Very good. I think if I remember correctly, did we make these things? Well, do we even have a semantics here? No, I put only alpha equivalence. Yes. Okay. Yeah. All righty. But it would be very cool at some point to make maybe what's it called? Now that I have finally learned how to make them, a notation for lambda calculus, a little elaborator, so that we can write actual lambda terms. We can do that later. You can see examples about how to do that as well. It's in languages for CCS. Well, that PR still needs to get in. I think it's a PR somewhere. PR here. Notation for CCS. So that we can actually write yeah, a quotation, and then you do whatever you want, a dot, plus, and so on and so forth. And in lambda calculus, we could do something similar. I mean, the syntax is not very surprising, actually. So we could also leave it like that for untyped lambda calculus, especially. Still, it might be nice for complicated terms, at least. Okay, dokie. Anything else we should talk about today?
Perhaps one follow-up, again, a PR from my side regarding cryptography 783. I just opened this recently, but perhaps one question, because I'm having linting issues, and I explained why, but I'm not sure if anyone is looking into the PRs before linting is fixed. That's why I'm asking. It's another quite big PR because, well, it's very it's not easy to split in this regard. But that's something I was working on my bachelor thesis, and I took some months to clean it up, and it's finally ready. But yeah, it's quite big. It's like 8,000 lines of lean code. So yeah, multiple PRs are going to happen. But I was just wondering if someone is going to look at it before the CI linting is fixed. That's my main question, not regarding the actual content of it.
Well, I think here a very good person to look at this could be Samuel. Let me check. We've also been talking to other crypto people to onboard them, so there will be more crypto people pretty soon, I think, to look at this kind of stuff. But this we should probably split it into more manageable PRs at some point. So maybe I should ask because you said it's pretty long, right?
This is only one. There's already one split of multiple. I'm not sure how to split this because it's theorem based from the original paper, and I gave some motivation in the PR text. But otherwise, well, we could probably split some. It's very connected, so I'm not sure how to split it into more content based PRs better than I currently have done. But well, I think someone has to look at the PR and decide, and I will do my best to help.
Yeah. Well, then I think the best thing to say is that is how to organize and polish fix this because of these lint errors. But I mean, this is interesting. This is interesting to have. So hopefully we can.
I mean, one thing I'm doing as a end result is to formalize some specific curves. I'm not sure if someone is working on this in cryptography currently.
I think that currently most people would be working on crypto primitives for and for signatures and that kind of stuff.
Yeah.
So probably not overlapping at the moment. But if you are in doubt, you can always ask in the Zulip. I don't know what all the crypto people are working on.
Yeah. Okay. Because I was just wondering, because I'm doing some primitive curve definitions, which I'm not very interested in to do myself, but I'm just doing it so my development has some nice examples, so to say. But yeah, that's just why I'm asking. But I might open another thread in CSLib and discuss it again. I did it multiple times during my bachelor thesis, but I think it got lost somewhere in the middle. But yeah.
Alrighty.
But there's no general rule that PRs are not reviewed as long as linting fails, for example, or is this a valid question?
No. I mean, they could be hard. I think though, it increases your. I mean, usually if somebody sees a small PR that passes CI, then sometimes if they have little time, they prioritize those because they can actually finish the review, right?
Okay.
Something like this will probably take a bit longer. So I would at least be happier if I knew that somebody is indeed looking at it.
Okay.
Or at least if they could tell us why they cannot look at it yet, and then maybe you can change it a bit so that they can review it. But I mean, we will see. Depends a bit on availability. With open source projects, it's all a bit random.
I mean, a note from Lambda Calculus that it's somewhat time constrained from Chris Hansen's side currently, which is not a problem, but sometimes you don't know if someone is looking, for example, into the crypto stuff or not.
Right.
Yeah. That's just to be verbal enough to be heard.
Yeah, it would be nice to have a bit of a system for, hey, I'm looking at this, but maybe in the near future, actually, it might make sense.
Yeah.
All right.
No, thank you.
Anything else from anybody? Nope. Then I guess we can adjourn and meet next week. Is that all right?
Okay.
Super
Great.
duper. Thank you so much, everyone. You have a nice day.
Thank you. See ya.
Bye.
Bye. Thank you.
Bye.